So in physics, a lot of times we are solving word problems or practice problems. And so what we're going to do here is we're going to discuss a strategy for solving physics problems, a strategy that can be used universally with most problems. And usually it helps you to sort of guide through the problem and what you want to, figure out what you want to answer and what you need to, some information that you know. So let's just define the parameters of how to solve a physics problem. Okay, so the first thing that we do when we read a physics problem, I'm going to do a sample down here, but really what we start with is we're going to start by identifying what is being asked of us. So after reading the problem, we're going to determine what is being asked and list it. And then the second thing that we do is, based on the problem, we're going to identify things that, information that's either given to us or things that can be known or inferred from the problem, and we'll list those. And then based on the variables that we need to solve for, we're going to identify the physics principles and, the equations that apply to that situation. Then after we've done all those things, we are going to do some work, manipulate equations, plugging in equations, or plugging in variables, and solving. And then the last step that we do is we write our answer, and our answer must include a unit always. Okay, so let's go ahead and follow this process for answering this simple problem. It's actually the first one from the classwork on speed and velocity calculations. So it says light from the sun reaches the earth in 498 seconds. If the sun is 1.494 times 10 to the 11th meters from the earth, how fast does light travel in space? So the first thing that we need to do is identify what we are being asked to solve for. So if we read it, the question says, how fast does light travel? So how fast is a speed or a velocity, right? So we're trying to solve for speed or velocity, right? And if we gave the velocity a direction like from the sun to the earth, then we would call it a velocity. If we just said the magnitude of it, it would be speed. But we essentially calculate them the same way because the light is traveling in a straight line. So number 2 says what things then is given or known. So some of the variables that are given to us in the problem is we're given the distance, right, or displacement between the sun and the moon. So we'll just call that d, or sorry, between the sun and the earth. We'll just call that d. So it's 1.494 times 10 to the 11th, times 10 to the 11th meters. And the other information that we're given is time, and we're given that as 498 seconds. Right? Now the third step is to identify the equation and physics principles that apply. So I'm trying to solve for velocity, and I know, and I'm given distance or displacement in time. So the physics principle that applies to this situation is that velocity is equivalent to distance or displacement divided by time. So now that I have my equation, all I have to do then is plug and chug. So I'm going to insert my variables and solve for the unknown. So I'm going to take 1.494 times 10 to the 11th meters divided by 498 seconds, and I'm going to go ahead and plug that into my calculator, and that will tell me my velocity. So 1.494 e to the 11th. This e button means times 10, so I just have to plug in the exponent there, and then I divide by 498, and I get this. And let me see if I can set it in scientific notation so it looks better. Oh, it won't do it for me. Yep. There we go. So you get 3e to the 8th. So the velocity is equal to 3 times 10 to the 8th. Now, whenever we write the answer, we also have to include the unit. So in this case, it would be meters per second. And again, if we were trying to write velocity, we have to indicate direction because it's a vector. So we'll just say velocity in order to give it a direction. We'll say from sun to earth. Alright, so this is a pretty simple example. It seems kind of like a really long way to answer something that maybe you could have figured out really quickly. But as we go on, there will be more challenging problems, and there will be things where we have to infer information here, figure things out. So it's sort of good to get into the habit of following these process, and as well as on the test, I will typically ask you to show your work, and this is what I am expecting.